welcome everyone to episode 6 of this series where we discuss energy management and risks. My name's Claire Agata and I'm the facilitator for today's session, and I'll ask our expert guests to introduce themselves in just a moment. The context for this session is that energy costs and energy availability, and if we take a couple of examples, we can think about organisations that have to cope with supply chain disruptions due to crises, wars. So if we think about things like the Ever Given container ship blocking the Suez Canal or the Strait of Hormuz being closed by Iran in the current war. Sometimes sources of energy don't exist anymore. So for example, the German government made a decision to stop atomic energy production. And also we have to contend with rising energy prices, which are due to rising global demand. So electricity demand growth, for example, is being driven by data centres, by increased use of air conditioning, electric vehicles, and industrial electrification. So because of all of this, organisations and in particular enterprises have to improve energy performance, and that includes energy efficiency, energy use and energy consumption, and they have to make sure that they have good energy availability. So energy is a critical resource, and its efficient use can actually lead to significant cost savings through lower energy bills, environmental benefits. That can improve competitiveness, and it can also give greater business continuity. Energy efficiency also contributes to climate change. So it contributes to climate change mitigation by reducing greenhouse gas emissions, and it can support compliance with legal and regulatory requirements. A reduced carbon footprint for an organisation and alignment with sustainability goals can offer real tangible benefits, but can also have a positive impact on an organisation's reputation. So that's our theme for today. And what I'm going to do now is ask my two guests to introduce themselves. So I'm going to come first to you, please, Deanne, if you can tell everybody a little bit about yourself.
Well, thank you, Claire. I'm very pleased to be here today to have an opportunity to talk with you and Frank about risks and energy management. I am the current chair of TC 301, and I have the privilege of working with some really amazing energy experts and liaison organizations as we develop a number of standards in the areas of energy management, energy savings, and energy terminology.
Thank you. And Frank?
Well, hello, thank you. I'm also very pleased to be here as part of the team. I'm a lawyer by education and a consultant to small and mid-sized companies. And also I work as an expert for DIN and ISO. I'm focusing on risk management, TC 262, and security management, TC 292. And I'm a member of JTCG, which is the a committee that takes care of aligning all the management system standards, which we've been talking about in this series of videos. Thank you.
Thank you very much. And I'm looking forward to talking to both of you. So we'll kick off with our first question. And that question is there any support for organisations when it comes to managing energy?
Well, we need to ask what an energy management system is and how it is governed, or how it is supported. And let me start with the last issue. It is supported by ISO 50001. An energy management system will integrate energy management into everyday business practices and procedures of any organization. So it will help save energy and money and help organizations reach climate goals. It should not be confused with building technologies used to manage energy. Diane, you want to go into some of the more detailed issues?
So an energy management system, we have found in doing a number of different market activities, there's really three reasons why organizations are strongly interested in doing this. First one is one that Frank brought up and most organizations think of first, and that's money. Energy efficiency allows you to operate things more effectively, and that tends to save money. This becomes important when we look at the second reason, which is greenhouse gas emissions, because in making that decision, there's sometimes a decision around a change in the type of energy they're going to be using or the sources of energy they're going to be using. As Claire mentioned earlier, electrification is a common example. But those decisions have costs and loss of efficiency in many cases. The third reason people want to do this is actually their partnerships and their agreements that they have with people who supply energy. These are sometimes shorter agreements, 1 to 2 years, but in many cases, these can be long-term agreements, up to 50 years. And those are very established partnerships. And so we have to manage that carefully. Can we go to the next slide, please? Let's take a look at some of the positive results that people have seen from implementing ISO 50001 in their organizations. We've divided this into two different viewpoints because the tactics and the strategies used are a little bit different in these two sectors I'm going to give examples in. The first is industrial. So you probably recognize Coca-Cola at the top. Most of these are from the US because I'm in the US. However, TC301 does have the benefit of having run an international case study competition for several years. And we have over 400 case studies from around the world in pretty much every sector you can think of. If you would like more information, let us know. But Coke looked at this, and in 3 years, they improved their performance in a Florida juice facility by over 12.2%. Land O'Lakes operations in Pennsylvania improved their energy performance by 5.7% in 3 years. And this resulted in $280,000 annually in savings. Another facility, industrial facility in Pennsylvania, was an Army munitions plant. They improved their energy performance by 12% in 3 years, saving $956,000. Let's go to the next slide. These are more the commercial facilities. Now, their strategies and techniques are a little different, but they still see amazing results. The first one is Aflac. This one is actually located where I am here in Georgia, and they have campuses in many places, but the one in Georgia reduced their energy by half in 9 years, saving a huge amount of money for them. The second one is Marriott, a hotel that's a global chain. Their goal wasn't energy savings, but customer satisfaction. Marriott is hotels, and they're very sensitive to their guest satisfaction. So while improving guest satisfaction is the main goal, they saved over 1 million kilowatt hours of energy. Just to give you an idea, that's 3.6 million miles for an electric vehicle. Google, we all know who Google is. They boosted their power factor by 3.5 while maintaining the same amount of energy use. That's an amazing improvement level.
So next, if you could please talk more about ISO 50001 and the family of standards.
Well, let's start with ISO 50001. It's a management system standard, and as such, it follows two principles. One is the so-called harmonized structure, which is an ISO directives principle, and the other is the so-called plan, do, check, act principle or cycle, which all management system standards follow. Plan, you are concerned with risks, objectives, energy review, energy performance indicators, and energy baseline, and data collection. Do, you implement the plan and the planning, design, check, you verify what was done and how it's working. Energy performance and energy performance improvement are the important base words, and act, review, and improve. Going from there, let's talk about the family of standards. The family of standards has 22 published standards and 3 standards are in development. They are listed in this graphics, in this figure. The most important one we have talked about a minute ago, 50,001. But there are 5003, 5005, and others. There is the standard on decarbonization, 5100. Measurement and verifications and energy savings, 5046, 5047. On consumers, there is 5007, and there is ISO 5044, and on terminology, there are 13,273-1 and -2. So this is a family, and we have listed here only the most important ones. There are more, as you can guess from the numbers, which is listed on the top left corner. Some key terms. We're talking about energy performance indicators. And what is energy performance? Energy performance is measurable results related to, well, number one, energy efficiency. As an example, you can improve boiler efficiency by 2%. This would be an energy performance indicator. Energy use. An example, replace fossil fuels with clean alternatives. Wind energy instead of power plants that are burning oil or gas. And energy consumption. Energy performance measured on energy consumption. The example would be reduce the total site energy use on kilowatt hours by 5%. So I think this is quite an interesting way of starting to talk about ISO 50001.
Okay, thank you for that, Frank and Deanne. Next, will you address risks and opportunities in energy management?
Of course we will, because 50001 is a management system standard following the harmonized structure. And the harmonized structure is asking all the end users to address risk and opportunities. First of all, there is the strategic approach, which is explored in clause 6. The control over energy, energy security, energy sources, asset management, and innovation. Also similar is tactical approach. Accessing energy data, set goals, plan and implement improvements. And there you go step by step into operational issues, which are regulated in clause 8. Data, significant energy uses, project for energy performance indicators, targets and action plans. All of this is done in the context of ISO 5001 and 50001, isn't it? And you address risk and opportunities. More in detail, I think Deanne is going in specific examples.
Okay, thank you, Frank. Frank is correct. Energy management addresses risks and opportunities throughout the entire structure of the management system standard, starting in clause 4 all the way through the standard clause 10. And we do have a focal point in clause 6, of course. One of the places in clause 4 where we start to look at those risks is in determining the scope and boundaries. And here you see an organization that has dotted lines, the pink lines around what they want to be their scope and boundaries. This is where they start looking at some strategic decisions in terms of the partnerships of what comes into those boundaries from the perspective of energy, and what goes out of those pink lines in terms of energy as well. They're also looking at a number of other issues, and that can include quite a few different considerations internal to the organization and the level of control. Let's look at the next slide. So here we have another organization. This time we used yellow boundary dots. But within those yellow boundaries, how do things move around? So transportation within those yellow boundaries is also an energy use. And so transportation would be included. There may also be partners operating within those yellow bounds. For example, many organizations have warehouse partners who operate within their boundaries, so within the yellow lines, but they are performing those activities. We have to understand the energy consumption and use and control within those scope and boundaries. So this becomes very important. We also have to understand what goes outside of those boundaries and how we deal with that. Some organizations do supply energy to other organizations that are outside their boundary. In other words, they're like a utility provider. Steam is a really good example. So the scope and boundaries becomes a very important way to look at the risks associated with your partners, your location, as well as what you have coming in and what you have going out. Let's look at the next slide. This leads us to a better understanding of why it is important to have a clear picture of what energy we use and where we use it. So here is a simple example of where do we use it. These are the different processes. This happens to be a metal example. And how much are we using? That happens to show up in the pie chart. This lets us understand where we should focus from both a strategic perspective as well as an operational and tactical perspective. Some of these areas may use more energy, but the asset management involved may mean that we simply can't make a capital investment. So we need to maintain energy performance in that area. Other areas may be areas where we can make improvements for non-capital investments or even some capital investments based on the strategic decisions of the organization. So this gives us a starting point for looking at how we might want to prioritize things. Let's look at the next slide. Because data is so critical in making those decisions, we really have to look at how we're going to collect that data. And we are going to collect data for each energy form. So for each energy form that we have, we need to collect that information. We need to understand that those forms come in different units and they're used in a variety of different places. So that will help us understand a little bit as we go on an energy journey. When we start the journey, we may only be able to start at that bill level. How much do we have coming in? That's a facility level discussion. As we journey or make progress in our energy journey, we may then be able to make it at lower levels, such as process, systems, or equipment. And this is going to represent improvements that we can make in our data collection. And that will help inform strategic and operational decisions. Let's take a look at the next slide. That's a tool we use within 50001 to start making those priorities based on risks. And we call that tool significant energy uses. It lets us take these different things and prioritize them based on specific risks. One of those is the data. That's your monitoring and measurement. So what can we get data from and at what level can we make decisions? Another is design and procurement. Long-term energy agreements are very real in this world. We need to understand what commitments we've made, and we need to understand what equipment and assets we have and how it's designed. Design has changed over the years, but many organizations operate equipment that can have been made many, many years ago. And managing those assets for capital investment becomes an important design decision, understanding how that is going to impact what energy sources we can use, especially if we've made commitments for GHG reductions, and what efficiencies we can expect. Operational controls come into play for our more tactical decisions. And then we have the people side. People represent a very big part of energy improvement. Simple things that you can even do around your own home, such as turning off lights, managing the thermostat, very simple things that can be done. So awareness and training are crucial. And then finally, improvement, managing those opportunities to get the best improvement we can. Let's take a look at the next slide. One of the most unique things about 50001 is that it requires mathematical demonstration of energy performance improvement. And to do that, you need a baseline. What am I comparing to? And you need a performance indicator, an energy performance indicator, or an ENPI, also called an NPI, to say, how are we doing? Some of those targets may be set to maintain a level of performance. That's a strategic decision, usually based on capital investment. And some of those are set on improvements, making things better, that energy performance improvement. And let's look at the next slide. But energy isn't always fully under our control. There are things that affect it. For example, if I am trying to keep things cold, so think of a cold storage that would send things to a grocery store, and I locate my cold storage in Alaska, and I have another cold storage located in, say, Texas. The average temperature in Alaska is about 40 Fahrenheit. The average temperature in Texas is more like 90 Fahrenheit or 32 Celsius. Those are very different. And it's going to take a lot more energy to keep things cold at 32 Celsius than it is for the site in Alaska. So you can see that in this graph on the left. That's called a relevant variable, things that affect our energy consumption, but we don't control, but we need to understand and have a strategy for. So the one on the left is showing you natural gas. So think about heating up a building in the winter. And this one happens to be from North America. And I can tell that because it's very low in the months 4 through 9, which is April through September. We don't need to heat buildings in North America between April and September. It's quite warm outside. We don't need heating. But in January through beginning of March and the last half of September through December, it gets colder. So we start to heat buildings. And you can see the slope of the lines coming down as you come toward March and going up as you go toward December, which is telling you you're using more. And it is the same as the weather, because the weather is represented by those blue dots. And you can see the shape of the two curves is roughly the same. So how do I deal with that when I'm looking at energy and assessing risks? Well, we model that. And the picture on the right is that model. So this is a linear model. Linear regression is a great tool. There's many other statistical tools. Linear regression being the simplest is used about 75% of the time. In other cases, the processes themselves or the complexity may require something more advanced. But in this case, we don't need anything more advanced. It's just a simple linear model of our natural gas consumption with weather. And we can see two basic things that pop out very quickly for us that offer both strategic risk and tactical risks and opportunities. So first is that green thing at the bottom that's called base load. So you see that the graph is offset. It doesn't come down to zero. That represents the amount of energy that's being used when nothing is being produced. So that's how much energy is going when you're not making anything. So that represents strategic decisions for capital investment in equipment, and it represents tactical decisions in how you stage or bring things online and load your equipment. Both of those decisions will show a difference in that base load, a reduction, which can be a step change in the energy consumption by the organization. The model then shows us how we're doing. How are we doing relative to what we should be doing? So the model represents what you want to do. That's the solid yellow or orange line going up. And then the one with the dots on it is what we're actually doing. So when the dots are higher than the line, we can make improvements. This is where we have risks related to our operational activities, and we need better operational control. When the dots are below the lines, we're doing better than our model. These are things we want to investigate and replicate. These are opportunities that we need to take a look at and explore in more detail. So let's take a look at the next slide. We want to take all of those opportunities that we identify and put them into our targets, our action plans, and have an ongoing list of those that we can continually action. Because some of those projects are going to lead to results that are better than we expect, and some of those projects are going to lead to results that don't quite get us the results we're looking for. Having a combination is what's going to get us demonstrable improvement against that baseline. And we need that improvement for our first audit if we choose to do third-party certification. So our initial certification audit has to demonstrate energy performance improvement. And then we need to show that same level of improvement or energy performance improvement at least once every cycle of external audits, or at least once every 3 years. From a managerial perspective, it is very fair for managers to come back and say, how are you helping me manage these risks and opportunities? How are you utilizing your resources effectively? Being able to demonstrate that in numbers and in dollars is something that helps management make key decisions, like which energy sources can I transition and electrify? Which sources do I still need to use because of long-term agreements? And how does my asset management come into play to make me a better organization? How does my operational controls reduce tactical risks? And so all of these measuring and monitoring activities and these objectives and targets allow us to demonstrate that clearly to management.
I see the target line, black dotted line at 400.
Yep.
This is meant to be the target for the sum of the 4 projects, A, B, C, and D, isn't it?
Mm-hmm. Correct.
Okay, so I understood. Thank you very much. Very interesting concept. Thank you very much.
Okay, so what will the future bring, and are there any new developments that you want to discuss?
Okay, yes, there are. TC301 gets a lot of ideas, and we have to manage and prioritize all of those things. And these are kind of the areas we're prioritizing. New areas, expanding areas of existing materials, and then, of course, the maintenance of our portfolio, which involves revisions. So some of the new topic areas where we're working in is AI energy. IDES, which is Integrated District Energy Systems, is also a very important and developing area. For expanding areas, we have a lot of work going on in M&V and calculations. A lot of this is driven by the need for management to demonstrate very specific information to key stakeholders, whether that's investors, banks, or whether it is for reporting. And that can be for public proclamation reasons, or it can be for regulatory reasons. If you're going to say that you have improved your greenhouse gas emissions from scope 1 or scope 2, how do you prove that? How do you prove that? Calculations are very important. And a part of those calculations is the projects that people have done. So how do you demonstrate that? How do you back those numbers up? That's what measurement and verification calculations are all about. And there's a need to show that at a variety of levels. We have documents that address that at a project level. We have documents that address that at a regional level, and everything in between. So if a government takes on a project to improve something, how do you demonstrate that? A good example of a project, let's take a university. Oddly enough, students in universities are pretty good at using microwaves and refrigerators. And just think how many dorm rooms there are in a university or even a boarding school. There are a lot. So the efficiency of those microwaves and refrigerators can become quite important. One university did a study on energy efficiency with refrigerators in their dormitory system and improved their energy efficiency by over 20% just by addressing refrigerators. And that didn't even include the microwaves. So you can get an idea that M&V becomes very important at different scales. And so that's an area that we are constantly developing. In the revisions, we are currently in the process of doing a number of market studies for what needs to be revised, including 50,001 and the auditing companion, which is 50,003, as well as in the terminology area. Our current market data is just now coming in. There is strong indications that there is a need to consider those revisions, and we hope to make that decision in the fourth quarter of this year about those revisions. So there's a lot of new things going on. There's a lot of existing work that's still being deciding how to prioritize, and there's some really cool new things happening as well.
Well, I think there's a very simple explanation for the example of the students and the refrigerators which you gave us. Students usually don't have the latest edition of a refrigerator, but an old one, an old type. So this is using much more energy than the new modern refrigerators.
It can, and that was one of their studies. In this case, the university actually provided the refrigerators.
Okay.
But they did find that in their older dorms were using more energy than in their newer dorms, which had the newer refrigerators. But they were still able, even in the newer dorms, to see some improvements in their refrigerators.
Well, that's easy. You only have to exchange the refrigerators, don't you? Diane,
You do. But
go ahead.
That becomes one of our favorite questions, and that is about as you look to replace equipment like a refrigerator, then it gets into some of the other sustainability commitments that organizations have made around waste.
Okay.
And a lot of our organizations do implement an integrated system with 9 and 14. And so we do have to do a little bit of balancing, and how often do we replace those versus how much waste are we creating?
Yeah. You're so right. Can you do me a big favor, Diane? I think everybody in our audience knows by now what AI is, but there are two more acronyms on this slide, EDIS and M&V. Could you help me understand those two acronyms, please?
Of course. IDES is Integrated District Energy Systems. So a good example of that might be a business park or a local community who has a steam system, and that steam is then provided as heat to buildings, and it goes out to all of the organizations in that area. Another example of integrated district energy systems might be small microgrids that have been set up for particular areas where energy reliability and energy security has been identified as an issue, and now they want to have smaller grids that can support that particular area. M&V is measurement and verification. It's also known as MVR, measurement, verification, reporting. And this is the methods used for how do you prove something actually did result in energy savings. There's not a dollar meter. So how do we know it actually saved any energy? So this is the methodology that talks about how do I know what it's using before I did something. So it sets up the requirements for the initial measurements, the initial picture, the baseline, if you will. And then you do the projects, and then you come back and you say what it did achieve. It's also known as commissioning, to see that it's performing the way it's supposed to if you installed new equipment. And then what were the actual results? Did you get the energy savings you hoped you would get? And it can define the approach, it can define the calculations, and it certainly can define the accuracy that those numbers need to be provided in. So that gives your investors, your banking organizations, and your regulators a level of confidence in the work that has been done. It also allows them to understand what it didn't do. So sometimes it wasn't a properly matched project and didn't produce the results it should have. Sometimes it is an excellent project and it gets much better results than it should have. But it lets us really understand what actually occurred and why.
Thank you so much. That helps a lot, I think. Let us look in a totally different area. Let us look into the integrated management system. And because there is something under development, which is a new standard, ISO 31011, which will follow the harmonized structure as an MSS Type B with recommendations and not for certification. Its recommendations can easily be integrated into any management system, including the energy management system. So this is what will come in the future, and what will this new standard offer? It follows the harmonized approach of the future. It's addressing risks separate but aligned to addressing opportunities. Systematic processes to identify, analyze, and respond to opportunities alongside risks to optimize overall performance. And added to this, it will recommend portfolio evaluation. Second, it will use the risk tree, and I'll show you in a minute what the risk tree means. It's a structured visualization to categorize and analyze sector-specific challenges effectively. And third, last but not least, it will offer a maturity model for self-assessment to provide an overall view of the performance of the organizations and its degree of maturity. Now first, addressing risk and addressing opportunities. Addressing risk. Addressing risk is very similar to what is done today in any risk management. You'll identify risk, analyze risk, evaluate risk, and either treat or respond to risk. That's on the left side, number one. Number two, addressing opportunities is very, very similar. It's distinct yet interconnected to the other process. It's identifying opportunities, like identifying risk. It's analyzing and evaluating. No, it's analyzing and testing opportunities. That's how it is called in the context of opportunities. And in the end, it's treating, or better, modern wording, responding to opportunities. Having done these, you will take the results and evaluate the combined portfolio. To do so, you'll compile the portfolio, you'll analyze the portfolio, and you evaluate it. And having done so, you better go back and look at addressing risk and addressing opportunities, because all of these processes are iterative. And if new issues arise or new perception comes up, you better have a look whether what you have evaluated before is still true today. The other thing is a risk tree, which I promised to show to you. The risk tree is meant to give some flexibility in the definition of risk. ISO doesn't agree on one for all definitions for risk. So the suggestion will be, or is, that we use the harmonized structure definition as a meta definition as a tree trunk, the effect of uncertainty, current harmonized structure definition. And then this tree will develop branches. Number one is risk faced by organization, management-related risk, which is very similar to the definition of risk as used by the family of 31,000. The second branch will be risk caused by organizations, created by, related to people, assets, products, services, or processes. And you will find this in 45,001, you'll find it in 14,971, and so on. And finally, the third branch is a new branch, which is just beginning to sprout and develop. That's a society-related risk. It's risk faced by society as a whole or relevant parts thereof. Examples are climate change-related risk or human rights-related risk. So you can see this tree will give the opportunity to be flexible with how risk is treated, is responded to, because all types of risk will be covered by the new standard. And with this, we are coming to an end, Diane. And we are inviting experts to join ISO TC 262 Working Group 11 and encourage their committees to liaise with the Working Group 11 in TC 262 to support a knowledge-based discussion for the new standard, because it's meant to help everybody that uses a management system. For my part, it's thank you very much for your attention. Diane?
I'd like to thank everyone for taking the opportunity to hear about risks and invite you to participate in TC 262 as well as TC 301. And thank you very much for all of your attention. And Frank, thanks for the great discussion.
Thank you.
And thank you, Claire.
Thank you, Diane, and thank you, Claire.
Thank you both. That was a fantastic episode, and you can see the contact information on screen as well if you want to get in touch with Frank or Diane after the session. But we'll bring it to a close now. Thank you again, Frank and Diane, and look forward to the next episode.